Question number 2 from the review. The graph of f and g are given as these. Let's talk about this. The first graph is f and the second graph is g. You need to find this limit. Now we learned from the limit laws that this limit can be separated as these two limits, and we need to find each of them and we can just add them. Okay, so limit x approaches to 2, f of x plus g of x should be these two limits separately. Let's talk about this first one here. So for that, you need to look in this graph. 2 is here. When x is approaching to 2 from left side, where are we approaching? -1. When x is approaching to 2 from right side, where are we approaching? -1. Because both sides we are approaching -1, this limit should be equal to -1. So we found this first limit is -1. Let's talk about the limit of g of x when x is approaching to 2. 2 is here. When x is approaching to 2 from left side, g of x is approaching at 2. And when x is approaching to 2 from right side, g of x is approaching at again 2. So this limit is 2. If we need to find the given limit, we need to add these two numbers. So -1 plus 2 would be actually just 1. Okay. Let's say if we change the question, instead of 2, we say we need to find the limit of this at 0. So we need to find f of x's limit at 0 and g of x's limit at 0 and then add them, right? So let's talk about this first limit. In f of x, when x is approaching to 0 from left hand side, function is approaching at 2. And when x is approaching to 0 from right side, function is still approaching at what? 2. So this limit is 2. F of x as x approaches to 0 is 2. Let's talk about g of x. As x approaches to 0, the function approaches, which number is that? 3. But as x approaches to 0 from right side, this new function is approaching to 1. So the left and the right limit for g of x at 0, the left limit is 3, and for g of x's right limit at 0 is 1. These are not equal to each other. Therefore, this limit does not exist. So we can't really find this limit. If that was the question, the answer would not be existing. Even if functions f of x's limit exist, the actual answer which we are trying to answer will answer that as does not exist. So I just wanted to do a little extra practice here. Okay. So in general, if, for example, when the question was just for 2, we were able to find it. But if the question was at 0, be careful. If one of the function's limit does not exist, the total limit does not exist. Okay, now let's work on question number 3, part A on the review. This is the limit of this expression. So think of it in my mind. If I try to put in 1, what will become? 1 minus 1 is 0. 1 square 1 plus 2 minus 3 would become 0. So just plugging in the 1 is not working. Okay, so that's not the correct strategy here. So what you need to do is you need to try to factorize the denominator, because there is a quadratic in the denominator. Let's try to factorize it. So this will be limit x approaches to 1. In the numerator we have x minus 1. In the denominator, I'm going to try to make this quadratic into two linear factors. So basically for that, I need to split 2 of x such way that product adding these two will become 2 of x and multiplying these two will become negative 3x squared. So let's try that. So I think it's x minus 1 and x plus 3. So if you multiply these two, you should be able to get, because it's 3x minus x should be 2x, and negative 1 times 3 should be negative 3. These are the factors. Now, because x is approaching to 1, x is not really equal to 1, so this is not equal to 0. I can cancel, reduce these factors by 1. So what is left here is 1. This limit would be equal to 1 by x plus 3. And now if I simply plug in 1, this will be 1 by 1 plus 3, 1 by 4 would be your answer. This here is question number 3 part. This is again a problem of the limits, but one of the, this is a rational function, and one part, the numerator here is radical. So the technique I'm going to use to find this limit is rationalizing. For rationalizing, I'm going to multiply and divide by it by a factor. Let's say, what do I do it with? See where it's coming from. This is coming from simply changing this negative sign to positive. Okay. Now remember, from your algebra, there is a rule: a minus b times a plus b is equal to a square minus b square. So this is a minus b and this is a plus b. So on the side, if you do root x minus 1 times root x plus b, using this rule, this would become root x square, which is x, minus 1 square, which is 1. That is why now, using that, I can write in the numerator it's x minus 1. In the denominator we have one factor x minus 1, and the other factor, I didn't distribute that, okay, for purpose. You can see I have x minus 1 in the numerator and denominator. Now x is approaching to 1, so x is not actually 1, it's very close to 1, so I can reduce this factor by 1. So what we have left is limit x approaches to 1, 1 by root x plus 1. Now we can try to plug it in. 1 plus 1, this will be 1 by 2. Here is the next part from question number 3. This is a limit involving trig, and if you check, when I try to plug in pi by 4 in the denominator, it becomes 10 pi by 4. Tan pi by 4 is 1, 1 minus 1 is 0. So that won't really work. So I need to simplify it. I'm going to try simplifying it using my trig identities. So numerator, I'm not doing anything, but this tangent can be written as sine x by cosine x. So if you remember from your trig, tangent x is equal to sine x by cosine x minus 1. Now this 1 I can write as 1 minus 1 by 1. Limit x approaches to pi by 4. In the numerator we have sine of x minus cosine of x. This part I can make first the common denominator as cosine x. For the sine x I don't have to multiply anything, minus this 1 will have to be multiplied with cosine x to make the common denominator. Limit x is approaching to pi by 4. I'm dividing by this fraction. When you divide by a fraction, what happens to the fraction is fraction actually flips. So I have this sine x minus cosine x in the numerator, but this cosine x by sine x minus cosine x really flips. And this factor can reduce to 1. So we are left with, this is limit x approaches to pi by 4 of cosine x, which is basically cosine pi by 4. Cosine by pi by 4 is root 2 by 2. Here is the last part of question number 3. This limit is pretty easy. This is a polynomial. If you remember the polynomial, the limit is simply plug in the value. So 4 times 2 square plus 5 times 2. 4 times 4 is 16 plus 10. The answer should be 26. So for any polynomials, limit is pretty easy. It's just like finding the value.